would like to review. I feel like I've been spending too much time talking on each session, which means I haven't been getting you to interact enough. So let's go through each of these principles from the top. We've actually made it down to pretty much the bottom of modeling with linear functions. So let's go over those two things. Let me just come up with problems on each and we'll have you solve them. Now I use a different kind of program for this, one that allows me to write on the page. Okay. Let me give you some equations. And you can tell me what you need to do, but mainly what I'm interested in is what the next line is. In other words, if you can always just read the next line to me, I know you've done what you need to do.
Okay. So that would be x equals 3.
All right, let's talk about.
Wait, because
let's talk about how we solve an equation. The last line needs to be this, right?
Yeah.
So the secret to solving equations is to get rid of everything that's affecting that x. And right now we are multiplying the x by 1/6.
Oh, it's 18.
Okay. In other words, we got to get rid of that 1/6. Now I can think about dividing both sides by 1/6, but a better way to think about it is multiplying both sides by 6. Notice that that crosses with that. I'm left with x all alone on the left and 18 on the right. But that's always the key. Let me give you a little harder one. Tell me the steps you need to take to get x isolated. And tell me the first thing, second thing, and so forth. What's the first thing you're going to do?
Multiply each side by 5.
Okay, give me the next line.
3x minus 4 equals 50.
Next line.
3x equals 54.
And last line.
X equals...
And it's okay to write it like this. And then realize, oh, I can simplify that. That's 18. 3 goes into 54 18 times. All right.
Got it.
And notice what we had to do there. We had to get rid of the 5. Then we had to get rid of the minus 4. And then we had to get rid of the 3. And that's always what solving equations are about. Okay? Now let me change it up just a little bit. Instead of the way I've got it there, let's make it this. Notice the difference. You see the difference between the two?
Yeah.
Okay. What's the best first step on the second one? The best first step on this one was to multiply both sides by the 5. But that's not necessarily the best step on the second one. There's actually an easier first step on the second one. What would it be?
I think you would add 4 first.
Correct. Yeah, so I would end up with 3/5 x equals 14. Now what's the next step from that?
Multiply by 5.
Okay, that's fine. So the next line is 3x equals 70. And the last step?
Divide by 3.
Okay. All right. I think you got that. You know how to solve equations in one variable. And that's what that first thing requires. Okay. Now, let's go to the second thing. Multi-step. Yeah, you even know how to do multi-step. We just did a 3-step equations. Okay?
Okay.
Now, the next thing is equations with the same variable on both sides using algebraic properties. Well, let's try something like this. The first step.
I would add 8 to each side.
Okay. Next step.
Then I would subtract 3a from each side.
Okay.
And then I would divide by 6.
So that's your answer, and that can be simplified. I can divide top and bottom by 3, so I end up getting 7/2. That's my true answer. And it doesn't matter if the A ends up on the right or the left side, same thing. Hold on. In the middle of a session, I'll call you back in 30 minutes. Fine. All right, let's see. Where was I? Okay, so you're pretty good at this first paragraph. Now, solving equations with more than one variable for a specified variable. Let's talk about something like the circumference of a circle. Okay, that's what the circumference of a circle is. The circumference equal to 2 pi times the radius of the circle. Solve that for the radius of the circle.
I would divide by pi.
What are you trying to get rid of? You're trying to get rid of the 2 and the pi, right?
So would you just divide by 2 pi?
Exactly. In other words, I would divide by 2 pi on the right and the left, and those cancel, so you end up with r equals the circumference divided by 2 pi. And that's also a true statement in geometry. And let me give you one more of those. It's a common one that they want you to do a lot. And that's that we've done this one before, but I'll give it to you again. The temperature in Fahrenheit is equal to 9/5 times the temperature in centigrade plus 32. Solve that for C, step by step.
I would subtract 32 first.
So read the next line for me each time.
Got it. F minus 32 equals 9 over 5 multiplied by C.
And read the next line.
Then multiply by 9/5. Oh, sorry. So then it would be
Hold on.
F minus...
Hold on. What am I going to multiply both sides by?
Oh, 5.
If I multiply by 9/5, nothing goes away. I get 81/25 on the right.
So just by 5?
5/9. You can do it in 2 steps, and I have no problems with that. And I think at the moment you should do these in 2 steps. So do it in 2 steps. What's the first step? You just said it.
Multiply by 5.
Read the next line to me.
F minus 32 times 5 equals 9 multiplied by C.
Okay, it's important to include those parentheses. You see why? In other words, this 5 has to multiply both the F and the 32. And that's equal to 9C. And what's the last step?
So it would be F, or you would divide by 9, sorry.
Okay.
So it would be...
And so all I have to do that is put the 9 over there. I don't need to go through this manipulation. Okay? So there's my answer. That's always what equations are about. When you're solving for a certain variable, the name of the game is to isolate it. Get rid of anything that isn't isolated. Now, notice when you did this in 2 steps, you multiplied by 5 and then you divided by 9, right?
Mm-hmm.
Could have done it in 1 step by just multiplying both sides by 5/9. In other words, when you have a fraction as that coefficient, all you have to do is multiply both sides by what you did in 2 steps. I'm going to do in 1. I'm going to multiply both sides by 5/9. That gets rid of that. That gets rid of that. Gives me my answer in 1 step as opposed to 2. However, if you're at all confused about it, don't do it in 1 step. The name of the game is to get the right answer, not necessarily to do it in 1 step. You understand what I'm saying?
Yeah.
In other words, if you don't know whether to multiply by 9/5 or divide by 9/5 or multiply by 5/9, then do it in 2 steps, just like you did it. All right.
All right.
Not bad on that. Let's go to the 4th point here. Solving and graphing inequalities. Well, I think you're pretty good on this, but I'll give you one anyway. Solve it. Oh, hold on. Excuse me. Sorry. This is not the kind they meant. They meant this kind. Solve that first, and then we'll graph it. Nope.
All right, so
hold on.
Just
Sorry. I don't have my tutoring brain back on yet here. Okay. There's an inequality. Solve that inequality.
All right. So you want the next line?
Uh-huh. Oh.
3x is greater than 15 and then x is greater than 5.
Okay. Now, this is an inequality in one variable, much like our equations that were in one variable. We were able to solve them for x. Okay? Well, when you graph this, you don't graph it on the xy coordinate plane, you graph it on a number line. Okay, there's 0, there's 5, there's minus 5. You know what I'm saying by just a single number line.
Yeah.
Now, how do I graph x is greater than 5 on that number line?
You go to 5 and then put a
Is it a solid dot or an open dot?
open dot.
Because it's greater than only, okay? And then what else?
And then have the arrow pointing to the right of it, like going on forever.
Perfect. Perfect. Okay. And let me give you another one. Let me think for a moment. I don't know how I can give you one that's a little different. Identifying functions. Just go through my book and make sure I'm not missing anything here. Yeah, this is kind of an interesting problem here. Tell me how to solve this. This is a one variable equation where I have a variable on both sides. What's the next line?
5x minus 20 equals 5x plus 12.
What's the next line?
5x equals, wait, sorry. No, that works. 5x is equal to 5x plus, can I just combine the 20 and the 12, which would be 20?
What you did was you added 20 to both sides.
Yeah, so then it would be 5x plus 12 plus 20.
Well, I combined the 12 and the 20, so I now got 5x plus 32.
Yeah.
What's the next line?
10x equals 32.
Hold on. How are you getting 10x?
I added 5x to both sides.
But you don't want to add 5x to both sides. You want to subtract 5x from both sides. In other words, regardless of whether I'm going to move this 5x to the right or if I'm going to take this 5x over here on the right and move it to the left, doesn't matter. I'm subtracting 5x from both sides, right?
Got it. So then it would just be x equals 32.
What's 5x minus 5x?
X equals 32.
5x minus 4x is 1x. What's 5x minus 5x? What's anything minus the same amount? Always equal.
0.
Now, what does that tell us?
That I can't do that.
Well, you can do that. What it tells us is that that is not an equation that has a solution. It does not have a solution. Not all equations have solutions. If you get an equation where you get one number equals to another number, and it doesn't have to be 0 and 32, if I'd have gotten 31 equals 32, well, I know something seriously wrong. And it wasn't my math, it was the original equation. Not all equations are going to have solutions. This is one that does not. Okay? Now, there's another one, a little similar, not to confuse you, and I hope this won't, but just next line.
Um, 3x plus 15 equals 3x plus 15.
What's the next line and what does it mean?
You could, okay, it would be 3x equals 3x.
Okay, that's fine. What's the next line?
0 equals 0.
Aha. So what does that tell you? What is the solution for x? Actually, this, you end up, yeah, you get 0 equals 0. If I subtract 3x from both sides, which I can certainly do. So what's it tell you? When we had 0 equals a number, it meant that there was no solution, right? But when I got 0 equals 0, that tells you that no matter what x is, this is true. In other words, the solution is all real numbers. I can plug in any value for x that you want. You can plug in 10, you can plug in 100, you can plug in minus 10. Doesn't matter the value of x you plug in, this is going to be a true statement. That's like saying x equals x. And it does for whatever value of x you put in. X does equal x. Okay? So there's a couple of oddball questions where it's an equation with one variable only, but it's got an infinite number of solutions. In other words, all values of x are the solution. Whereas the previous one, there were no values of x. So equations have three possibilities. They can have no solution, they can have exactly one solution, sometimes two solutions, or they can have an infinite number. And an infinite number merely means that all values of x satisfy that equation. All right, let's go on. That's pretty good for that part right there in terms of review. Let me make a little bit more space here. We'll go down to the second portion and we'll do some review here. Identifying functions. Well, let's do it graphically first of all. I'm going to draw a bunch of things and you tell me whether they're functions or not. Is that a function?
No.
Why?
Because it doesn't cross like 0.
Doesn't need to cross 0. Here's the definition of a function. For every value of x, you only have one value for y. Okay? Well, if I look at that value of x right there, and I don't even care what number it is, let's just, that's the value of x I'm concerned about. There's the value of y. If I look at this value of x, make sure you understand what I'm saying here, that you understand this. That's the value of y. If I look at this value of x that's right there, that's the value of y. Notice that for every value of x, I only have one value for y. That's the definition of a function. Okay, you with me?
Yeah.
I'm going to draw some others on there. Hold on. Quite mastered this drawing program yet. That a function?
No.
No, because when I look at this value of x right there, I get that value of y, but I also get that value of y. Okay, so there is a direct violation of what a function is. You cannot have one value of x producing two different values of y. And the way you easily can tell is to think of the vertical line test. In other words, functions always pass the vertical line test. Pass, 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 fail. Fails the vertical line test right there. So when you're looking at a function graphically, the best way to tell if it's a function is by imagining a vertical line test. Okay?
Okay.
Is that a function?
No. Well, yes, actually.
Good. Is that a function?
No.
Now, make it a little bit harder. And this is when it does become harder, is when they give you a table of x and y values. There's going to be my x values, there's going to be my y values. Is that a function?
Yes.
Good. Is that a function?
No.
Why?
Because there's a 1 and 4 and then a 4 and a 1.
Okay, the way to express that is that for an x value of 1, we have two different values for y. In other words, in this case, when x is 1, y is 4, and in this case, when x is 1, y is 2.
Got it.
No, that is not a function because it violates that basic premise. Now, these can get a little tricky. Hold on, I'm going to give you another set. I can figure out how to... Hold on. Is that a function?
No.
Why?
Because when x is 3, there's two y values.
It's okay. What you can't have is... Oh, my mistake. Hold it. You're absolutely correct. It's not what I wanted to put up there. I wanted to put this.
It's okay.
That's what I want.
That's a function.
That is a function. Even though I've got two y values that are the same, they come at different x values. In other words, this does not violate the definition of a function. Remember what the definition is that for any value of x, you have two different y values, or for a given value of x. Whereas this is, I've got the same y value for two different values of x. If I wanted to graph this, well, there's x of 3, y is 1. There's an x of 2, y is 2. There's an x of 1, and y is 1. And then there's an x of 6, and y is 4. Notice that even if I were to connect those dots, which you don't always necessarily have to do, but if you do, that's a function. That passes the vertical line test. So it can be a little tricky. This is a function, but when I had two x values that were the same with two different y values, that was not. And that's the thing you're always looking for, to disqualify it from being a function. All right, Phoebe, I'm going to let you go.
All right.
And this is good. This is exactly how we should do this, is make sure we spend enough time on review to keep you engaged. Because I've kind of felt like the last couple sessions I talked the whole time. And that's never the best way to learn. That's what you get when you go to class. Your teacher talks for an hour at you. Okay? Best way to learn is for you to interact with me. So I'm always asking you questions, you're always answering. If you get it wrong, I'll correct you and tell you how to do it right. But I'm a firm believer that this is the way to do it. Okay?
Okay.
Phoebe, have a nice weekend, and I'll probably talk to you next week.
Yep.
I don't have you scheduled for anything next week, so make sure your mom knows and go in and schedule whatever she wants.
Sounds good.
All right, bye-bye.
Bye.